Graders, we're on our last example for the day, and we're still in section 6.2. I just got to put a little bit of information up here on our last set of examples, our last 4 questions that we're going to cover and delve into today. Okay, first thing I want you to do, I am not going to do example 4 at this moment. What I need you to do right this second is pause the machine. Go get some notebook paper because we need some background information before we tackle any of this. In example 4, we need some background information. Your book just didn't do a good job doing that. So pause me. Go ahead and do it right now. Okay, welcome back. I hope that you have your notebook paper and your pencil. Remember, we don't do stuff in pen in my class. And that you're ready to take some notes on some basic exponent rules. And this is where we're going to start, okay? Rule number 1, if you multiply a base times another base, and that has to be the same variable, can't be 2 different variables, the rule doesn't apply when the variables are different. It's a variable times a variable, same variable. Then what you're going to do, very simply, is you're going to add the exponents together. Now let me show you why that is, okay? Let's do this one together. Let's do x squared times x to the 4th power. Now I'm going to show you the expanded view, and then I'm going to show you the shortcut, and they're going to be the same answer. And we don't want to do the expanded view all the time because it's a lot more writing and a lot more work. But I'm going to show it to you, all right? So we're going to expand it out. We're going to write x squared. Well, x squared is x times x. Okay, now let's put a big multiplication sign there, and let's do x to the 4th. That's x times x times x times x. So there's the expanded view. Now let's ask yourself this question. How many x's do you see multiplied together? I see 1, 2, 3, 4, 5, 6. I see 6 x's multiplied to each other, and that gives me x to the 6th power. Okay, now here's your shortcut. X squared times x to the 4th, notice we have the same base. They are both x's. Excellent! Little pun there. We need to use our rule here, base times base. We're going to take those 2 exponents and we're going to add them together, and we're still going to get x to the 6th. Okay, let me show you another one. Let's do y to the 3rd times y to the 10th. Okay, if I expand it out, there's 3 y's here, and there will be 10 y's here. Okay. All right, how many y's do you see being multiplied together? Count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 y's being multiplied together. Or you could just do the shortcut. Hey, same base. We've got same base being multiplied together. So let's add our exponents together. And it's y to the 13. Now, if you get comfortable enough that you don't need that step in between, you don't have to write it. You can go straight from here to here if you so desire. It's really, what are you comfortable with? Do you recognize when you have base times base and you can add the exponents? Now, the rule doesn't apply if you have 2 different bases. You can't use the rule here. Not the same base. You got to leave it alone. There's your answer. It's already simplified. Can't do anything else when they're 2 different variables. Hey, but if they're the same variable, then you can. When you multiply those variables together, you can add those exponents, okay, and simplify it that way. All right, continue down your page. Let me get to the next rule. This is our second rule. Just did rule 1, base times base, add the exponents. Now we're going to do base divided by base. And the rule states that you should subtract your exponents, okay? So let's do a raised to the third power divided by a to the second power. Okay, so if I expand it out, put 3 a's up top and 2 a's down bottom. Now what happens when you have a number divided by itself? Well, that cancels to 1. Cancels to 1. And look what you're left with. A. Okay, that's expanded view. Or you could do your rule and go, hey, I got a to the third divided by a to the second. That's really 3 minus 2, which is 1. Okay, got the same exact answer. So the rule does work here. So it's real easy when the bigger exponent's up top. That's really easy. What happens when the bigger exponent is on the bottom? Okay, well, in expanded view, we'll put 2 a's up top and 3 a's down bottom. And you see your a's cancel out. All that's left up top is a 1, an understood 1. So that's what you write. You don't write 1 or you don't write 0. You write 1 because that's what's there. And then you have an a left on the bottom. Okay, and some of you are like, but how does the rule work, the subtraction rule work? Because when I do 2 minus 3, I get negative 1. Hey, but you know what? You can rewrite a to the negative 1 as 1 over a to the positive 1, which is 1 over a. Same thing I got here, and here. They are the same. Now what I do in this situation, I oftentimes kind of bypass the subtraction rule, especially if the bigger number's on the bottom. And what I'll do is kind of a cancellation process. And I'll go, both of these a's, both of them will cancel with 2 of the 3. That means I have 1 a left over. And I'll do 1 over a that way. Now I have done it that way. I'll show it to you again. Let's say I've got 5 a's up top and 7 a's down bottom. All 5 of these are going to cancel out with 5 of the 7s. So that means I have 2 left. And I'll have 1 over a squared. And I've done it that way before too. So just some wrinkles here. I just want to show you some of the ways you can handle it if you're in the situation where you have base divided by base. Now, when does the rule not work? When you have 2 different bases. These are not going to cancel. You're stuck. That's your answer. You can't use the rule when the bases are different. The rule only works if the bases are the same. Okay? It's truth. So, rule 1, base times base. Add the exponents. Base divided by base. Subtract the exponent. All right, let's get to our third and last rule. What if you have power to a power? Well, you're going to multiply the exponents. So what does that look like exactly? Let's just say we got x squared and we want to raise that to the third power. Okay, the rule says I have a power raised to another power. I'm going to multiply these 2 numbers together and get x to the 6th. So that's what it looks like when you use the rule. What does it look like if you expand it out? Well, in expanded form, x squared raised to the third power, all that means is I'm writing x squared 3 times. So here I go. I'm going to write it 3 times. That's x squared raised to the third power. And then, remember rule 1, base times base, I'm going to add these exponents together, and I'll get x to the 6th power. Now, I don't really see the necessity of expanding this out when all you have to remember is if I have an exponent raised to another exponent, or a power raised to another power, just multiply the 2 together. So you could have a situation where you have like x to the 4th, and I'm raising that to the 1/2 power. Well, just multiply the 2 together, and you'll get x to the 2, because half of 4 is 2, so it's x to the 2. So power to a power. So let's review. Base times base. Yes, add. Base divided by base. Yep, subtract. Power to a power. Multiply. Okay, so let's go back to example 4. Because now that we have some background, now maybe some of this stuff we're getting ready to do is going to make some sense to you. Okay? All right, so let's start with letter A. We've got the cube root of x to the ninth, y to the third. Well, that's really, you're not going to be able to do that in a calculator, so we need to rewrite it. So maybe we can do some simplification using some of our exponent rules. So let's rewrite the radical so that it's not a radical anymore, it's actually a fractional exponent. Simplest way to do it. Take your base x, okay? And remember, when we undo the radical and turn it into a fraction, you take the exponent on the x and you divide it by the index. Remember, that's your index. That's going to become your denominator. Do the same thing with the y. Take your exponent, which is 3, divide it by the index. And then just simplify these two fractions here and here, and you'll end up with x to the third, y to the first, or in other words, x cubed y. And that's as simple as I can make it there. Now, to use your power rule that I just taught you, power to a power, you could rewrite this as x to the ninth, y to the third, put that in parentheses, and raise it to the 1/3 power, because the understood exponent on the entire radical is 1. So you could write it this way and then do power to a power like this, where you do 9 times a third and then 3 times a third, and you'll get the same thing, okay? Same exact answer. You could do power to a power. I like this first way that I did right here. I like that method better because it gets to your answer much more directly is what happens here. I think you will end up liking it too. Now letter B, we've got, we have a power to a power situation, so they took it out of the radical for us. This is, we've got to take x squared, and actually it's not a radical because it's not a fraction, exponent on the outside. So we've got x squared times y to the 1/2, and then we're going to take both of those and raise them to the 4th power. That's power to a power. We have power inside the parentheses, and we have a power on the outside of the parentheses. So we're going to take the x and do 2 times 4, and then we're going to take the y and do 1/2 times 4. That's what's going to happen in that first part, okay? Now the second part right here, what you have here is the cube root of y to the third. Remember what I said. If the exponent on your base is the same number as the index for your root, they're going to cancel each other out, and you're left with good old y. Okay? Now let's clean this one up. We got 2 times 4, there's 8. And then we've got half of 4 is 2, and then we've got this extra y here on the end. Now it's not quite simplified because I don't need y written twice. I need to write y just once. Now look at what the situation is. I've got y squared times y to the first. That's base times base. They're both y. Base times base, we're going to add those exponents together. So bring that x to the 8th over. Nothing changes about that. I don't have another x to combine with it. And what's 2 plus 1? Yep, 3. And there's your answer. X to the 8th, y to the 3rd. Okay? All right, letter C is kind of like letter A. I'm going to solve it the same way I did letter A. I'm just going to take x. It already has an exponent of 4. Divide that by the index. Y has an exponent of 12. Divide it by the index. And you'll have x to the first, y to the third, or in other words, xy to the third. That's as simple as I can make it, folks. Or you can do power to a power and say, I'm going to raise x to the 4th, y to the 12th, and I'm going to raise that to the 1/4 power. That creates that power to a power situation, and you'll have x to the 4th times the 4th, and then y to the 12th times the 4th, and you'll still get x to the 1st, y to the 3rd, xy to the 3rd. It doesn't matter. It's just, how do you want to solve it? It's really up to you. There's just so many ways to manipulate these numbers and to use the rules that you were taught. And you were taught quite a few rules in this section alone. All right, let's get to letter D. We have power to a power. Now, if I kind of expand this out a little bit better and bigger, you'll see that x doesn't have an exponent on it. That just means it's an understood 1. Y has an exponent of a half, and we're raising that to the second power. Okay? And then we are to take the fifth root of x to the fifth. All right, so power to a power. Let's focus on the numerator. Power to a power. X to the first, raise to the 2. What's 1 times 2? You're right. That's x squared. Okay? Y to the 1/2. Raise to the 2. What's 1/2 times 2? You're right. That's 1. Okay? Denominator. Remember what I told you. If you have the same exponent and it matches the number in the index, that means they're going to cancel each other out, leaving you with an x. Okay? Now we don't want x in 2 different places. We just want to write this thing one time. Okay? So there's a little more simplification that can be done. I have base divided by base. Now the exponent on the 1 in the bottom, I have 1x in the bottom, 2 x's up top. Remember what we said? Base divided by base. Yes, I'm going to subtract. So what's 2 minus 1? 1. And so I have x to the first, y to the first, or very simply, xy. Okay? So hopefully by kind of preempting our lesson with some basic rules about exponents, we were able to see some of the ways that we could maneuver and simplify these very difficult problems. So we're going to spend quite a bit of time on example 4, because examples 1, 2, and 3 can all be done in the calculator, and that's easy. Example 4, not so much. And I want you to feel confident in this particular process. So we'll be working on this quite a bit. So kind of anticipate that, okay? Thank you for listening. Please bring your questions to class.